Hastable. Hastable implements map interface and are associative arrays with key and value pairs. Similar to the hash map we have discussed. The keys are unique but unordered. Both key and value should be objects. Java primitive types should be wrapped before they can be used. Hastable comes with 4 constructors. Constructor without a parameter, constructor with the initial capacity, constructor with the initial capacity and load factor, and also a constructor with a map interface. Hastable also has synchronized methods. Let's look at an example. In this example, I have imported 2 classes, Hastable and Enumeration. I have created an object of Hastable at line 7 using the default constructor. Further, from line 8 to 13, I have added elements to the hash table as key and value pairs. 1. The words of the numbers being the keys and the integer objects being values. If you have noticed at line 14, I have re-added a value for the key 3, which is already existing in the hash table. At line 6, I have called the method hashtable.keys, which returns me an enumeration of all key elements. Further, I have extracted the value of a key by getting the next element from the enumeration object. And then I pass the key object to the method get of the hash table, which returns the value. Now let's run this program. Here is the output. As discussed, the order of insertion and order of retrieval of a hash table may not be the same. And further, you would notice that the value 3 is being overwritten by value 300. That is, if the same key is produced to a hash table, it would overwrite the same. The methods of a hash table are synchronized. Hash map. A hash map is similar to a hash table. It can store nulls both as keys and values, whereas a hash table cannot store nulls as its keys. However, keys are supposed to be unique. The methods of hash map are not synchronized, whereas the methods of hash table are synchronized. As discussed, the keys are unique but unordered. Like hash table, hash map also has 4 constructors. Hash map is faster than a hash table. It's used for mapping keys to values. Let's look at an example. Here is an example of a hash map. In this example, I have imported the hash map, set, and iterator interfaces. I have created an object of hash map at line 8. Further, as discussed, hash map is a collection of key and value pairs. I have added keys and values from line 9 to line 13. As you see here, 1, 2, 3, 4 and 5 acting as string keys, and then integer 1, 2, 3, 4, 5 as values mapped to the keys. Further, at line 15, I am overwriting the key 3 with the value 300. And as discussed, hash map allows null keys. In order to justify the statement, I have also added a null key and a null value. At line 18, I have extracted the key set. By calling the method keySet, it returns me a set object. I had extracted the iterator from the set object, calling the iterate method. As we have earlier discussed, iterator acts as a pointer into a collection. Here, the set refers to the key values. Further, I have constructed a while loop to retrieve the keys and then retrieve the values from the hash map by calling the get method. Now let's run this code. As discussed, null can be added to a hash map. You can see the same here. And then the key 3 is being overwritten with the value 300. You may try on this example from the Java workbook. Tree map. The class tree map implements the sorted map interface, and as discussed, also is an association of key and value pairs. Tree map forms a balanced tree on the key elements of the tree map. A tree map consists of unique keys in sorted order. Tree map also comes with 4 constructors. Tree maps are used in order to keep your data in a sorted order. Now let's look at an example. Here is an example of a tree map. In this example, I have only replaced the hash map of the previous example with a tree map. As discussed, tree map sorts the data on the key elements in an ascending order. Further, key map does not allow null keys. Now let's run this code. As discussed, the key map orders the data on the key element. Here are the key elements sorted in an alphabetical order. Now what if I want to sort custom objects? In such a case, you would need to implement the comparator. Let's see another example on how to do that. Here is an example of tree map using custom key and custom value objects. In this example, I am using student as a key and student marks as values, where student object is mapped to student marks object. In In this example, I am using a student comparator which was earlier used in an example with tree set. Now let's look at the classes student and student marks. This is the class student, which has student ID and student name, with the constructor which takes student ID and student name. And further, I have added the getter and setter properties with a toString method. Here is the student marks. In this example, I have defined 3 marks elements and a student ID. And then I have a constructor which takes student ID along with the 3 marks. And further, I have also overridden the toString method. Now let's look at the student comparator. The student comparator class implements the comparator interface and overrides the compare method. The compare method, as discussed earlier, has 2 objects. It extracts the value of the objects and then compares the 2 values using the compare to, returning the difference between the 2 names, using which the tree map sorts the data. Now let's go back to the tree map demo. In this example, I have added 4 student elements mapped to student marks by the names Tom, Jim, John and Harry. Now let's run this code. Here is the output. In the student comparator, I have compared the student names to sort the data on the student name. The order of storing the elements, as you see here, is reversed. Harry is the first one, followed by John, Jim and Tom. You may refer to this example from Java Virtual Guru.